Hello students, welcome to this lecture number 9 on Ionic Equilibrium. In this lecture, we will be going to discuss the buffer solution. First, let us understand what is the necessity of understanding the buffer solutions. What do we need it? Because there are some biological and environmental processes which requires a constant pH in the solution. As for example, our blood. Blood is having the pH of 7.4. And to maintain its consistency is very much essential for our body functions. In case there is any change of the pH, there will be the dysfunctions in the body. The body will not able to perform well, and that will going to create different kind of disease. Now question arises, how do we maintain the pH of any solution, which is a paramount important. So in this lecture we will discuss the buffers actions and relating the buffer solutions, and this can be achieved with the help of the buffer solutions. So today's heading of this video is buffer solutions. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So what we mean by buffer solution, let us first understand. Buffer solution is a solution in which there is a consistency in the pH value, and even we drop some amount of acid or base in that solution, there will be no change in the pH. Either it is in dilution or either it is in putting of the acid or bases. This is called the buffer solution. So we can write the buffer solution is a solution And what is buffer action? Buffer action is the principle of the solution in which the solution going to resist the change in the pH. Buffer action is the principle of the solution, change in pH value. So it is the principle by which the pH value will remain constant. As for example, suppose we have taken one beaker which is having the water, and in this water the pH of the water we know that is the 7. Suppose we put some acid. What is going to happen? The pH will change, decreases to 3. And another vessel, another beaker we have taken, where we put some base, and its pH, suppose p value is 7. Now after putting the base, it will be around 12. But instead of that, if we put the buffer solutions, suppose we put the buffer solution, what will going to happen? The pH will be 7, it will just marginally decrease, it will be 6.8. Or in case of, if we put in this some buffer solution here, the pH will 7 to just there's a marginal increase 7.2. So if we give some buffer solution in that H2, that we see that if there is a very marginal increase of the pH, that is the buffer solutions. And the action of this maintaining the consistency in the pH is called the buffer action. Now we are going to discuss very important thing, the type of the buffer. Types of buffer. There are different types of buffer you can see. Number 1, that is salt buffer. Salt buffer, the example of the salt buffer is ammonium acetate. Ammonium acetate. It is prepared from the weak acid and weak base. Weak acid is acetic acid and weak base is ammonium hydroxide. Then another type, that is the acid buffer. Acid buffer, that is the weak acid, its composition will be weak acid plus the salt of same weak acid plus strong base. And its example for the acid buffer is acetic acid and sodium acetate. This is the salt of same acid, that is acetic acid, with is NOH. NOH is the strong base. And third number, that is the basic buffer. Basic buffer. Basic buffer is basically the same way that we have you can understand easily, that is it is the weak base plus salt of the same base with some strong acid. NH4Cl and NH4OH. Strong acid and strong base also be act as a buffers. Strong acid of 0.01 mole of HCl can be work as a strong acid buffer. 0.01 mole of NaOH also can be act as a strong basic buffer. So in this way you can see this will be the types of buffer. Now question arises how the buffer acts, how they are maintaining the pH. That we will now discuss. Question arises how buffer acts. Let us take the example of the acid buffer. Acid buffer, we know the buffer solution consisted the acetic acid, weak acid, and is salt of strong base. Weak acid, what is going to happen? It will dissociate in the aqueous solution very little way. So you will see the aqueous solution that will be like this. Now the base, this is the salt. The salt also will be, salt is dissociated completely because it is a salt. We know salt is a very strong electrolyte. So what is going to happen when we add, now which we add some H plus ion, means we are adding some acid. So when we add acid, what is going to happen? The H plus ion will be increases, and at that time you will see this is the base. The conjugate base is a very strong base, you know. Weak acid always produce the conjugate base which have the very high strength. So this will add with this conjugate base, and when you put the acid, it will be transformed into the weak acid. So when it is being conformed, when it is changed into the weak acid will not much going to be dissociated. So the H plus ion will be maintained. There will be no change on the H plus ion, means the pH will remain constant. When we put some OH minus base, means acid matlab we have put some H plus ion, or base means we have put some OH minus ion, concentration of OH minus ion higher. At that time the H plus ion that is created by the acetic acid will react with this OH minus ion, and it will produce the H2O. So in this way the OH minus ion also controlled, and also the H plus ion will be controlled with this action. This is the base, conjugate base will take the H plus ion, and the already produced H plus ion will consume this OH minus ion, or we can say this base is being neutralized by this acetic acid. So in this way you can see there is a buffer action. The pH of the solution remains fixed. Now question arises, how do we able to calculate the pH of the buffer solution? And for this we have the relationship, that is this two relationship you can see for the acid, for acid buffer, and this relation is called the Henderson's relations, Henderson's equation. And the Henderson equation says, so the Henderson's equation Hasselblad equations basically. This equation say for the acidic, when there is acid buffer, the pH will be pKa plus log of concentration of salt by concentration of acid. The concentration we are talking about the molar concentration, and Ka is the dissociating constant of weak acid. This relation can be further be modified pH in terms of the conjugate base, because you can see here there is a conjugate base is produced for the acid buffer, conjugate base. So we can write this relation with this way: pKa plus log of conjugate base divided by concentration of acid. This is for the acid buffer. But what about the basic buffer? For basic buffer, you have the another equation. This equation is given by, that is the pOH. Here pOH is given. On this pOH we have to calculate the pH, and you can see pKb plus log of concentrated salt divided by base, weak base. Here Kb is the dissociation constant of weak base. Dissociation constant of weak base. Okay, so we get this. Again we know pH is 14 minus pOH, and from this we can also calculate. Also we can have this relationship further modified, that we know pOH, pKb. Here what is pKb? pKb is minus log. pKb is minus log of Kb. So pKb plus log of conjugate acid. Here conjugate acid will be there. Concentration conjugate acid and concentration of base. So these are the equation, and this equation will be very much helpful. We will see later on that this will help you to determine the pH of the buffer solution. You can able to prepare yourself some buffer solution which meets your requirement. So how this is, in this way we can all this equation, and this equation will be used for calculation of the buffer, so pH of the buffer solutions. Okay, this is one very relevant questions, numericals, that I have given you. That is for preparing a buffer solution of pH 6 by mixing sodium acetate and acetic acid. The ratio of concentration of salt and acid should be 1:10, 10:1, 100:1, and 1:100. And you have been given the Ka of the acetic acid is 10 to the power minus 5. How do you calculate that? You have to prepare a buffer solution which will have the pH 6. So we can use the Henderson's equations, and this is pH equal to pKa plus log of concentration of salt and concentration of acid. We have to calculate the concentration of ratio of the concentration of salt and acid to achieve this pH 6. So we will put this pH 6 and pKa, that is given. pKa is basically minus log of 10 to the power minus 5, and we will get the log of salt that we have to calculate, basically salt divided by acid. Okay, so what we will do, 6 it will be 5 plus log of salt by acid. So what we get from this, the log of salt by acid, it will be log 1, it will be coming 1, sorry, it will be coming 1. So we know 1 means log 10, so from this we can write again log of salt by acid, it will be log 10. So salt by acid solution will be 10 by 1. That is the option B is correct. So if we take the buffer solution with the ratio of the salt and the acid is 10:1, with this buffeting agent is acetic acid and sodium acetate, we will get the pH 6. Okay, that how we can able to prepare a buffer solution which is desired pH that can be governed and determined by the amount of the salt, of the weak acid, and the amount of the concentration of this acid, and that is really very much helpful to understand. Okay, very good question, good numericals that you can see. Which of the following buffer solution turns invalid on addition of the 10 milliliter of 1.0 mole HCl? You can see this is the buffer solution, and having this constituent buffeting agent is ammonia and ammonium chloride. Okay, now when we put this HCl, what is going to happen? Now it will neutralize this NH3 and it will become the NH4Cl. So we have to see in which solution this amount of HCl will totally neutralize this ammonia, and so in the solution, after the neutralization solution, it will left with only ammonium chloride. So ammonium chloride is not a buffer solution. For buffer solution you have the base with its acid, salt, base with its salt. So if you see that neutralization of this HCl with 10 milliliter HCl means 10 millimoles of HCl, and here it is given 15 millimoles of NH3. So there still remain the 10 millimole neutralized 10 millimoles of NH3, so it is excess 5 millimoles of NH3 after neutralization. So it will remain as a buffer solution. Similarly, we will see also it will also be remain as a buffer solution. Okay, this also be as a remain as a buffer solution. But here you can see the things here that 0.05 into 100 millimeter means 10 millimole of NH3, and you have been given the 10 millimoles. The solution is 10 millimoles. So you can easily understand it will totally neutralize this present ammonia, and it will, in the solution, you will having only the ammonium chloride. So the buffer solution will remain invalid. It will no longer a buffer solution. Okay, it is very important and very useful to understand. So that is all for today's lecture. In this lecture, we understood what is a buffer solution, how the buffer acts to maintain the pH. We also know different types of buffers. We also know how to calculate the pH of the buffers. And you know that is in the blood we have the buffer system, that is the bicarbonate buffer. In this blood you will find the NaHCO3 and there is the carbonic acid. This is the buffer system in the blood. In this system, that the same way that it will able to maintain the pH. And if the pH varies more than 0.2, then there is a chance of death of this man. Okay, so buffer action is very much important for our biological system or many types of things. So that is all for today's video. If you like this video, we will share to your friends, and I am 100% sure you will be benefited out of that. Thank you very much for seeing.